In this video, Assalamu alaikum. In this video, we'll talk about vapor pressure. So what is exactly vapor pressure? So if we have a liquid in a container and this container is closed, and this is the liquid here, and we have molecules of the liquid, right? These molecules will be attracted to each other by intermolecular forces, one of the intermolecular forces. If we check one molecule inside the molecule and one at the surface here, so we will find that the one inside will be attracted to all molecules from all sides, but one at the surface will be attracted only from both sides and from down. It means this one will have less intermolecular forces. If it has less intermolecular forces, it means that he needs less energy to break this intermolecular forces and convert it to a gas or escape from this liquid. So if he wants to escape from this liquid, it will be easier for him than molecules that located inside the liquid, because it needs less energy because it's less attracted. So he needs less energy to break these intermolecular forces and to convert it to gas or a vapor. And actually this is what happens. So here we will have at the surface, so this molecule can easily convert it with no heat. So there is no heat here. What will happen? It will be only absorb heat or energy from the surrounding, and it will be use this energy to break the intermolecular forces and to convert it to vapor. So we will have vapor molecules over here. So one by one we'll start to convert to a vapor. So we'll have this one. So we have 1, 2, 3, 4, and more molecules will convert it to vapor. And here, as more molecules will convert it to vapor, and this container, we know that this container is closed. So we will have here high pressure of these vapor molecules. So we will start to have a reversal process. So we have an evaporation and still we will have condensation. So we will have two processes that will happen at the same time. We will have evaporation from the molecules at the surface, and then these molecules was already converted to vapor. It will again come back to the liquid and convert it to a liquid again. So we will have two reversal processes which will be happening here. At some time, after a time, we will reach to equilibrium. And when we reach to equilibrium, so the rate of evaporation will be equal to the rate of condensation. At this point, we will have number of molecules over the surface. These molecules will exert a pressure on the surface of the liquid, and this pressure will be called the vapor pressure. So the vapor pressure is the pressure done by the liquid molecules or the vapor molecules over the liquid. So what will happen here? We talked about, or we have only one liquid, but what will happen if we have a liquid and another substance? So we will have a solution now. So what will happen if we have a solution? So if you have a solution here, let's take, this is the pure liquid, and the pure liquid only have molecules of this liquid. So these molecules of the liquid will be converted to vapor. But if we have a solution, so we will have two components here. We have liquid, which is a solvent, and we have solute. And we will take the solute as non-volatile, so it cannot be converted to a vapor. So this is here, this one. So this will be the solute, and this solute is non-volatile, so it will not convert it to a vapor. It can't convert it to a vapor. So what will happen? What is the difference between the two cases here? So this one we have pure liquid, so all the molecules at the surface can convert it to vapor because they are liquids. But here, this one, we have at the surface number of the solute, which is non-volatile. So the number of the liquid molecule at the surface, which have the ability to convert it to vapor, will be less than the number in the pure liquid. So this means that when we measure or count the number of the molecules that already can convert it or will be converted to a liquid, we will see that number of molecules here will be less than this case. Why? Because the solute here, molecules will occupy part of the surface, and when they occupy part of the surface, it will decrease the number of the liquid molecules that can convert it to a vapor. So if you have a solvent, only a solvent or a liquid, so it means that pressure will be a high pressure. But if we add non-volatile solute, so this non-volatile solute will decrease the vapor number of the vapor molecules, so it means the pressure will be less. So here we have less vapor pressure than if it's pure, and this is actually which is Raoult's law. So we have Raoult's law. He indicate or state the relationship between the vapor pressure in for a pure liquid and vapor pressure for the same liquid when it will be in a solution. So vapor pressure for a solvent will be equal to X for this solvent times the vapor pressure of the pure solvent. So this will be the vapor pressure for the pure solvent. And this X, it will be the mole fraction for the solvent, and BA is the vapor pressure for the solvent in the solution. So the vapor pressure in the solvent in the solution will be equal to the mole fraction for this solvent times the vapor pressure of the pure solvent, which will be only liquid with no solute. Okay, let's have an example here. So the vapor pressure of a pure water at 20 degrees is 17.5 torr. So this is the vapor pressure. So this is vapor pressure for pure H2O. So this is the first information. And what is the vapor pressure of water over a solution? So it means that here water will be in a solution. So this is the vapor pressure for the water inside the solution of the solvent. This is unknown. When it will be made, the solution will be made by dissolving 15 grams of glucose C6H12O6 and 15 grams of water. So what we have two components of the solution. We have solvent, which is H2O, and we have solute, which is C6H12O6. We have 50 grams of each one of them. Okay, let's see exactly what Raoult's law stated. So Raoult's law said that if you want to calculate the pressure of a solvent, so it will be equal to the mole fraction of this solvent times the pure pressure or the vapor pressure of the pure solvent. Actually, we have the vapor pressure of a pure solvent, this one here. So in order to calculate the pressure of H2 also, we need to calculate the mole fraction first. So let's remember again, what is the mole fraction? Mole fraction, it means the ratio between moles inside the solution. So mole fraction for H2O, it will be number of moles of H2O over number of moles of H2O plus number of moles of C6H12O6. So it's moles of H2O compared to the moles of the solution, which is solvent and solute. So we need to calculate this. We need to calculate number of moles for H2O and number of moles for C6H12O6. So let's do this one. So first, I will calculate the number of moles for each. Here. So to calculate number of mole for H2O, so it will be 50 grams of H2O times the 1 mole of H2O over the molar mass, which is 18 grams of H2O. This will give us exactly now how many moles do we have of H2O, which will be 2.78 moles of H2O. I will do the same for C6. So it will be 50 grams of C6H12O6 times 1 mole of C6H12O6 over the molar mass, which is 6 times 12 plus 6 times 16 grams. So this will give us 0.278 moles of C6H12O6. Now I will use these moles to calculate the mole fraction. See, the mole fraction of H2O will be equal number of moles of H2O, which is 2.78 moles, over again number of moles of H2O plus number of moles of C6, 0.278. This will give us the mole fraction for H2O, which is 0.91. And remember, always the mole fraction will be less than 1. So now I will substitute in the formula for Raoult's law. So the pressure of H2O will be equal to the mole fraction, which is 0.91, times the pressure for the pure solvent, which is 17.5 torr. This will give us the mole or the pressure for H2O as a solvent, which will be 15.9 torr. Okay, another example. Okay, so here again we have glycerin, and glycerin is a non-volatile liquid. So this one is a non-volatile. And what is the vapor pressure of a solution that made by adding? So we have a solution, and for the solution, we're adding 164 grams of glycerin, which is a solute. Okay, and 338 milliliters of H2O, which is a solvent. So what is the vapor pressure of pure water? So we need to calculate the vapor pressure of H2O. This is the unknown. And he gave us as the vapor pressure of pure H2O at the same temperature is 54.74 torr. And also he gave us the density. So first, again, we need to calculate the mole fraction. So in order to calculate the mole fraction, so I need to calculate number of moles. So I will start by number of moles. Here we have grams, so we can convert it to number of moles. So it will be 164 grams of C3H8O3 times 1 mole, conversion factor 12 mole for C3H8 on O3 over the molar mass of this one. So it will be 3 times 12. Plus 8 times 1 plus 3 times 16 grams. So here we can have number of moles. It will be equal to 1.78 moles of C3H8O3. Okay, this is the, now we need to calculate number of moles of H2O. So actually we don't have the mass of H2O to calculate number of moles. So first we need to get the mass of H2O. So what we have here, we have V of the mass and we have density. So we know that density is equal to mass over V. So it means that from this one, we can get the mass. So mass of H2O will be density times V. So mass will be equal to 338 milliliters times V, which is, sorry, this is V, times density, which is 0.992 gram per centimeter cubic. So it will be 0.21, no, it will be 384.89 grams H2O. Now I will convert this mass into moles. So it will be number of moles of H2O. So I will do it here. So it will be 384.89 grams of H2O times the 1 mole of H2O over the molar mass, which is 18 grams of H2O. So it will be equal to, number of moles will be equal to 21.38 moles of H2O. Now I will go and calculate the mole fraction for H2O. So the mole fraction of H2O will be number of moles of H2O, which is 21.38 over, again, number of moles of H2O plus number of moles of glycerin. So it will be 1.78. So it will be equal to 0.92. Now we can calculate the pressure of H2O will be equal to 0.92 times the pressure of pure H2O, which is 54.74 torr. So this one will be equal to 50.36 torr.